So I made this video today because some of you are still struggling a little bit with graphing histograms and understanding what's going on, and of course dot plots and also box and whisker. So this is a little review, and those of you here in my strategies class will find this very familiar. So for a histogram, guys, what we're doing is deciding which data fit into certain ranges. And we have to make sure that our intervals are even. Looking at this data here, I noticed that the smallest value is 100, and the biggest value, I think, was maybe 156. So I made my smallest value down here 100, and then my largest value 160. And that's going to help me to be able to fit all my data onto the graph. So what you do is you want to find out how much data, or how many data pieces fit between, first of all, between 0 and 110. And remember that's, between 100 and 110. And remember that's actually 100 to 109. Anything that's 110 would fit into this category here. All right, so let's get started. Between 100 and 110, we have 1, 2, 3. Looks like 3. So from 100 to 110, we would make our first bar like this. You can color it in if you want to. You don't have to. And between 110 and 120, let's see what we have. We have 1, 2, 3, 4. Looks like 4. So we're going to go up to 4 for that bar. We have 4 pieces of data that fit into that interval. Okay, now from 120 to 130, we have 1, 2. We don't count 130 because that goes in the next group. 3, 4, 5, 6. Am I right? I've missed one. Then you guys can make the correction on your paper. 120 to 130. And then from 130 to 140, I have 1, 2, 3, 4. So I'm going to go up to 4. From 140 to 150, I have 1, 2. So that only goes up to 2. And then from 150 to 160, I just have my one little piece of data left right here. So that is how you make a histogram. Here's one more example of a histogram. It's dealing with the number of seconds it takes to download 30 apps, and I've made my range. I found the smallest piece of data was 17, so I made my lowest 0.10 and then my highest 0.70 because I don't think there's any value above 70. So in order to fill this in, we need to count how many data points, first of all, are between 10 and 20. Let's see, we have 1, 2, 3, looks like just 3. So we go up to 3 and make our bar like this. Then we need to know how many are between 20 and 30. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if we were in class right now, I'm thinking that you guys would be saying, Miss Holt, you made a mistake. Because I saw it as I was counting these. From 10 to 20, I left one out. There's one. So that means my bar needs to go one more up. All right, from 30 to 40, let's see what we have. 1, 2, 3, 4, 5, 6, All right, so between 30 and 40, we go up to 6. Now from 40 to 50, I have 1, 2, 3, 4. So for this one, we go up to 4. From 50 to 60, 1, 2, 3. And from 60 to 70, we have 2 pieces of data. So I'm not going to go into the analysis of this bar chart right now, of this histogram. I just wanted to show you how to do one, remind you how to do one. All right, this is a review of how to make a dot plot. In this problem, we have 20 students who recorded the number of hours they spent using a computer over the weekend. And we're going to plot that on this number line right here. They've set it up for us because they saw that the lowest value and the highest value would fit between 4 and 12. We wouldn't have any data that couldn't be put on the graph. But for a dot plot, it's similar to a histogram, but we're plotting individual points of data. So what I want to do first is find out how many students spent 4 hours using their computer. That's what this data is. So I'm going to count. I have 1, and looks like just 1. So I make 1 dot here. Okay, now I'm looking for how many students spent 5 hours using the computer. And let me see here. Looks like I don't have any. I don't see any students who spent 5 hours, so I don't put anything right here. Now I'm going to see how many students spent 6 hours using the computer. And let's just write that at the bottom so we can remember. It's always good to label things. These are the hours that we're talking about. And then these dots represent the number of students. All right, so 6. Let me see. We have 1, 2, 3, 4. 1, 2, 3, 4. All right, how many spent 7 hours? 1, 2, 3. 1, 2, 3. How many spent 8 hours? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many spent 9 hours? 1, 2, 3. 1, 2, 3. How many spent 10 hours? 1, 2, 3 as well. 1, 2, 3. How many spent 11 hours? Looks like we had 1. And then that's it. We didn't have any who spent 12 hours. So again, I'm not going to get into the analysis of this dot plot. I just wanted to remind you how to create one. And here are 2 more examples for dot plots. The ages of the top 2 finishers for American Idol, seasons 1 through 12, are listed below. So here are their ages. So we want to label our graph like we did before. These numbers down here along the number line are the ages of the contestants, and then over here the number of contestants, or the number of finishers that had that age, or that were that age. So let's see, let's start with 16. Do we see any 16s? Yes, there's 1 and 2, 3. So 1, 2, 3. 17, 1, 2, 3. 1, 2, 3. 18. None. I don't see any who are 18. Let's look for 19. I only see 1 who is 19. 20. 1. Just 1 who was 20. Now let's look at 21. We have 1, 2, 3. 1, 2, 3. 22, 1. Is it just 1? And then 23, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For 24, 1, just 1. For 25, 1, 2, 3. 1, 2, 3. 26. Don't have any 26s. I have a 27. And then I have 2 29s. Okay? And then down here at the bottom, 10 mayors recorded the number of sunny days experienced in their cities last summer. So our numbers down here represent the temperatures, and then our axis here, or our dots, represent the number of days that had those temperatures. Okay? All right, so again, this one's shorter, a little bit easier. So 77, we have 1, just 1. 78, we had 1. Again, 79, we have 1, 2, 3. 1, 2, 3. 80, we have 1, 2, 3, 4. 1, 2, 3, 4. And then 81, we had 1. Okay. Okay, and here's a reminder about making a box plot. We have here, hitting close to home, making a box plot out of the algebra test scores that were given below. These are some pretty good scores. But the first thing we have to do, if we're making a box plot, because we know we need the median, if we got to find the median and the first and third quartiles, we have to put the data in order. So this was the data it was originally given, the way it was originally given to us. But I went through and put them in order. The lowest data piece was 60, then 65, then 72, and I just marked them out as I went and put them in order. That's really important. Put the data in order. In order, from lowest to highest. Do that first. All right, now we can find our minimum. These are the 5 pieces of data, pieces of information that we need. So we can find our minimum. That's easy. That's going to be 60. And our maximum is 100. So I can come down here to my graph and I can put a line here at 60 and a line here at 100. Then to find the median, we have 15 pieces of data. And there are a couple of ways to do it. But we know that the median is the middle number. We need the same amount of data on the left side as we have on the right side. So if we count from the outside in, 60 and 100 go together, 65 and 98 go together, 72 and 95 go together, 75 and 90, 75 and 89, 77 and 83, 80 and 83, and we find that this 81 is right in the middle. 1, 2, 3, 4, 5, 6, 7 pieces of data on the left side. 1, 2, 3, 4, 5, 6, 7 pieces of data on the right side. And that's because 15 is an odd number. You know, sometimes we end up with 2 numbers in the middle and we have to average them. So that's our median. And we can graph that down here. 81 is going to be about right here. And then Q1 and Q3 are the median of the lower half of the data and the median of the upper half of the data. So the median of the lower half of the data, we have 1, 2, 3, 4, 5, 6, 7 pieces of data here. So if we choose the number 75 here, it looks like we have 3 pieces of data on the left and 3 on the right. So that means that Q1 is 75. Okay, this was our median. And if we look on the right, we find that 1, 2, 3, 4, 5, 6, 7. So if we choose 90, let me put it in red like the rest of them. If we choose 90, then we have 3 pieces of data to the left of it and 3 to the right. So that is going to be our Q3. Okay. Okay, so our minimum is here, our maximum is here, the median is here. Now Q1 is 75, that's going to go right here. That's Q1. Q3 is 90, that's going to go right here. And it looks like a lot of lines right now, but the way we draw it is we connect the median with Q1 and Q3, and then we connect the box to the min and the max with these lines that we sometimes call whiskers. And let's just do one more. This is the speeds in kilometers per hour of 14 roller coasters. The first thing we said we have to do is put the data in order. I didn't do it ahead of time this time. We're going to have to do it together. So let's find our minimum piece of data. Looks like the lowest one is 85. So 85. We have two 85s though, or actually 3 85s. Okay, then the next biggest piece of data would be 90. And put commas between them so we can keep them separated. 92, 93, 95. Hope I don't skip one. Then we have, looks like 104, but we have two of them, so 104, 104. Then we have 105.6. Then 107. Then 120. 128. And 149. Okay, it's a good idea to count your data. Make sure you got them all. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're good. All right, now we got to find our 5 important points that we need. The minimum, that's pretty easy, and max. Okay, I'm going to make my graph in red this time, I think. So the minimum is 85. Let's find that. It's right here. The maximum is 149. That's going to be about right here. Then we got to find the median. So how many pieces of data did we say we had? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have an even number of data. 14 pieces of data. So that means we're going to have to average the two middle numbers. So if we count from the outside in, and I know you can't see both sides of this, but 85 goes with 149. So I'm counting in these two, 85 and 128, 85 and 120, 90 and 107, 92 and 105, 93 and 104, and I come to 95 and 104 as being my two middle pieces of data. So I have to find what's directly between 95 and 104, and you can just figure it out if you want, or you can add the two together, 95 plus 104, and divide by 2. And if we do that, we get 95 plus 104 divided by 2 equals 99.5. So that is our median. Okay, so finding 99.5 down here is probably about right here, right? That's where our median is. Now we have to find Q1 and Q3. Q1 and Q3. So Q1 is the median of our lower half of data. Now here's a little thing that we haven't talked about before. If we end up with two pieces of data in the middle like that, we're actually going to divide the data like this. We're going to include those two pieces of data. We didn't do that for the other one when we had an odd number of data pieces. Here we have 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. So we know that we're only going to end up with 1 in the middle down here, and it turns out it is 90, right? Because that means we have 3 over here and 3 over here. It's right in the middle. So if I put my 90 here, that's my Q1. That goes here. And then my middle piece of data over here is 107. That means I have 3 pieces of data to the left and 3 to the right. It's the one that's right in the middle. So 107 is going to be about right here. That's my Q3. All right, and it looks like just a bunch of lines, but when we connect them, our median with Q1 and Q3, and then we connect the whiskers to the min and the max, that's our box plot.